In this task, we're going to look at the current, voltage and resistance in series and parallel circuits. It might be a little bit small, but hopefully you've got your sheet in front of you to have a look at as well. So we start up in the top corner, over here. Current in a series circuit, well, the rule for current in a series circuit is it's the same anywhere in a circuit. So if this is 10 amps, then ammeter 1 is going to be 10 amps, and ammeter 2 is going to be 10 amps. Same rule here, so again, it's the same everywhere. So if that's 1 amp, then the others are going to be 1 amp, and so on. 4.3 amps, and 4.3 amps, and 1.2 amps, and 1.2 amps. In a parallel circuit, the current splits. So if we had 10 amps coming this way, and 8 amps went down here, the remaining 2 amps would go over here. So this answer is 2 amps. In this example over here, we've got 2 amps coming over here. We're going to assume the light bulbs have equal resistance, and so the same is going to go down here, which makes 2 amps. So our total here must be 4 amps. Again, in this circuit, we've got 7 amps coming in here. We're going to assume that A3 is the same, 7 amps, which gives us 14 amps going through the top. Here we've got A1 is 12 amps, and again, we're going to assume that there's an equal split, so we've got 6 amps and 6 amps. Over to the potential difference, or the voltage. So in a series circuit, the voltage across each component adds up to the voltage across the power supply. So in this example here, we've got V1 is 3 volts, V2 is 2 volts. So this one plus this one must make 3 volts. So 2 plus 1 volt is going to give us 3 volts. In this circuit here, this is 9 volts and this is 5 volts. So this plus this must equal this, which would make that 4 volts. Over here, we've been given V2 as 7 volts and V3 is 4 volts. So the sum of these 2 voltmeters will equal this voltmeter, which will be 11 volts. And finally, in this one, this is 8 volts. So again, we're going to assume that the potential difference is split equally between both. And so they're both going to be 4 volts. In a parallel circuit, remember our rule for voltage is the same everywhere. So if this voltmeter is 2 volts and this one is 2 volts, this one is also going to be 2 volts. If this voltmeter here is 6 volts, again the same everywhere, so they're both going to be 6 volts. Same idea, 7 volts and 7 volts, and again 9 volts and 9 volts. So now if we come down here to have a look at resistance and explain those rules, in a series circuit, if we call this resistor 1 and this resistor 2, then the simple rule is that the total resistance is the sum of all resistors connected in series. However, in a parallel circuit, if we call this resistor 1 and resistor 2, then the total resistance is always less than the smallest resistor. So it's always less than R1 or R2, whichever one is smaller. Moving on to our challenge question over here, we need to see if we can work out the missing values. The only one that we've got is that voltmeter 1 here is 12 volts. Remember, because it's a parallel circuit, remember the voltage is the same everywhere. So if this is 12 volts, then we know that voltmeter 2 will also be 12 volts. We can then use our equation, potential difference equals the current times the resistance, to work out the current going through here. So for working out current, we know that V over R equals I. So the voltage was 12, the resistance was 10. So 12 divided by 10 will give us the current through ammeter 1, which is 1.2 amps. We can do the same thing over here. We can see that again, we've got our voltmeter of 12 divided by our resistance to give us the current going through A2, which is, oh, I've written that one in the wrong place, which is 0.6 amps. And then finally, we can work out ammeter 3 because we know it's the sum of our other 2 ammeters, which will give us 1.8 amps. So if we're feeling confident that we can apply the rules to the series circuit, I'm filling over here. And if we're confident that we can do the parallel circuit, we can fill in over here. Well done.